Hello guys, welcome to my channel. In this video, I'm going to show you the advanced geospatial analysis with Turfjs. So Turf is the JavaScript library which is used for the advanced analysis of the spatial data. So using this module, you can directly calculate the area, bounding box or bearing center, etc. And then also you can like do the coordinate mutation, flip, rewind, round. And also in the transformation section, there will be some analysis functions like buffering the area and then making circle or making concave and convex hull. And also it support the different kind of spatial operations like union, and then differentiate between two polygons. And then also it has some transformation, coordinate transformation things. So here are, you can see, as you can see, here are lots of features available in Turfjs. So basically we can do every kind of operation using this library. So I'll just going to demonstrate some of the most useful features using Turfjs. So let's get started. So here I created the index.html file, inside which this is the simple HTML code, and then I created the map div. And inside map div, my width is 100%, 100%, and height is 100 vs. And here I loaded the already loaded leaflet through CDN, and then I loaded the Nepal district.js, which is inside here. It's the district GeoJSON file. So we are going to deal with this data type. So yeah, if you want to work in my dataset, I'll provide you the all the code and data link in the description below. And here is another file called Nepal district headquarter. So that means the point data in GeoJSON file. So maybe I'll also link this data Nepal district SQ. Yeah, so yeah, I linked two dataset, Nepal district and Nepal HQ, and then I initialized the map to the center of this latitude and then this longitude, and then zoom level to 8. And I by default I added the OSM base layer. So it will look like something like this. So here you can see the map is zoomed into the Nepal, and then it's uh, zoom level is this 8. So let's add this Nepal district and Nepal district HQ file as well. So for that, I have to check the variable name. So here in the Nepal district shape file is the Nepal GeoJSON data, and then this one is SQ data. Okay, let's add this feature. So for adding GeoJSON data, you have to add the yal.geojson and then variable name Nepal GeoJSON data, and then you have to add to map. And then let's add another one as well, yal.geojson, and then Nepal HQ dot add to map. So let's see. So here the district file is loaded. So maybe the headquarter is SQ data. Sorry, this name is SQ data. So SQ data add to map, and then now headquarter is loaded into the map. So this marker represent the headquarter of each district, and then this polygon represent the Nepal district boundary. So yeah, this is the basic way to load the GeoJSON data. So maybe I'll create the layer toggler for this district before I getting start into Turfjs. So for that, just I'll name it as the Nepal district, and then okay, maybe I'll add later, and then this one to the Nepal HQ. And then I can Nepal district dot add to map, and then Nepal HQ dot add to map, and then I can make the base layer OSM, and then I can make the other layers Nepal district and Nepal district and Nepal headquarter, Nepal HQ. So after that I can just add this to the control control layer, and then base layer, and then other layers, and then maybe false false dot add to map. So this will dot control dot layer is not function, sorry, typo error. So layers, not layer. So this will add the this controller here, so we can check this district and headquarters shape file based on our need. So this is the this is the basic structure. So this PSED maybe collapsed, collapsed is equal to false, means it should not be collapsed after that. So let's get start with this Turfjs. So first thing is I want to calculate some of the measurement things. So let's calculate in the Nepal district shape file. So for that, let's calculate the area first. So here for calculating the area, you can pass the on each feature property, and it will take the function feature and then layer, and then you can pass to the area. So area should be equal to, sorry, I have to activate the turf as well. So let me go to the Turfjs documentation, and then cdn. Okay, and then turf.mean.js. So I'll just copy this URL, and then after this leaflet I'll add this URL here. So the area, then after that your turf will be activated, and then you can calculate the area using turf dot area, and then you can pass the feature. So if you console log the area value, and it will area of each feature will be available in the console. So let's see. So here it shows the area, so here the turf dot area is undefined here. So maybe I think it's the issue of the turf link. So maybe if I check the turfjs this GitHub page, it shows the Syrian link here. So maybe I'll just copy this link and then replace this old link with the new one. So basically here what happened is the this one is the Turfjs link of 0.0.124 version. I don't know what this mean, but if we replace this link with the latest one from the turf 5, turf version 5, so it should work. So let's see in the yeah. So the area of each feature is showing here. So maybe we can customize little bit this area field. If you check the documentation in area, it says that it returns the number area in the square meter. So maybe we can make it to square kilometer. So for that the area will be the dot, not dot, divide by the 4560, so it will be in the square kilometer. And then if you check this, so here you also got this long field which is not necessary. Up to 2 digits it okay for us. So we can apply the javascript function of on number to fixed, and then we can fix it to the 2 digits, up to 2 digits. So here you can see the now area, this represent the square kilometer. So maybe we can pop up this field. So for that I'll remove this console log, and then I can put here layer dot bind pop up, and then I can use this syntax which is the JavaScript ES6 syntax for string, and then I can just write my HTML here. So area in the bold tag, this B means bold tag, and then I can pass the JavaScript variable inside uh, this money sign, and then the dollar sign, and then the curly bracket. So inside I can put the area. So layer dot bind pop up. So let's see if we click on each feature, so it will give us the area of the current this polygon. So in the similar manner we can calculate the center. So for calculating the center, there is the function called turf.center, and then we can pass the feature. So if we console log out the console.log center, it will give us the lat and long of the, I think it's the GeoJSON of the center. So from this feature, from this GeoJSON, what we need is we need only this coordinate. So for that what we can do is center. Maybe I can write the center lat, and then I can just go to the each feature, and then inside feature we have to go to geometry and then coordinates, and then get the first one and second one element. So for that this actually in Turfjs I think this one is longitude, and then this one is latitude. So we can go to the turf.center, and then get the geometry, and then coordinates, and then I can get the one means the first value will be 0, and then second value will be 1, and then center long will be turf.center feature, and then get the geometry, and then coordinate, and then 0. So if I add this here, maybe /br means the break line, and then I can again put the b tag means the bold, and then cntr center x comma y, it will be the, and then I can pass this money sign and then curly bracket, and then I can, maybe I'll just write it in the small bracket. So center long, and then center let, and then I can close this. So yeah, now if I, center is not defined. Oh, this one we completely removed and write lat and long, that's why. So if I click on any polygon, and it will show the area and center of the polygon. So if you check in Turfjs documentation, in the center you can find the how to calculate the center of the polygon. So it work on polygon, but it work on the point data as well. So here in the example it shows it created 3 points in the map, and then it calculate the center of these 3 points. So basically what it does is it will create the bounding box including these all three polygons, all three, I mean markers, point data, and then it will just get the center, I think. Yeah. So okay, uh, now we can calculate the bounding box as well. So let's calculate the bounding box as well. So for the bounding box, there is the function called turf dot bounding box, and then we have to pass the feature. And then if I console log here box, and then okay, it will provide us the javascript array. So by default this kind of array we cannot add directly into the pop-up, so maybe we need to convert this array to the string, and then we can add it to the pop-up field. So for that, maybe I can just change the type to string, uh, and then I can just add here, maybe I'll just slash br means break line, and then b means bold text, and then BBOX and slash b, and then I can provide the bounding box. So maybe in here box, and then I can just write like this. Okay, let's see how it looks. So if I click here, you can see the bounding box. It's not completely included in this pop-up field, so maybe we can change this. So here we have to change the style of this pop-up content wrapper, pop-up content. So okay, here you can see in the leaflet pop-up content, it styled the width with 301 pixel. So if we change this to the maybe 500, then this error will be solved. Maybe 600 is better, I think. 600. So for changing this, maybe we need this class, and then just copy this class, and then we have to style this here with 600 pixel. Still not solving, maybe we can overwrite it. So yeah, here it is working now. So the pop-up field is appearing with the full text. So in this way you can add the area, center, and BBOX. Let's try other features as well. So if it's the a line length, the line, and then we can calculate the distance as well. I mean, if it's the point, we can calculate the distance as well. If it's the line, then we can just calculate the length as well. So yeah, so in this way you can uh, add the advanced analysis like measurement controls in the pop-up field like this. So now let's start the end section. So here maybe I'll create the show you the how to create geometries using Turfjs. That means we can create dynamically the point and line and polygon features, even the multi-point, multi-line and multi-polygon features, so which is included here. So the point, for calculating point, you just need to assign the point of dot point and then longitude and then latitude. So and then you have to add this point to the map. So let's try. Maybe I'll write turf GeoJSON. So let's create the var point, and then point will be turf dot point, and then you have to pass the coordinate longitude and then latitude. So maybe I'll pass this coordinate. So okay, let me paste it here. So one thing just keep in mind in Turfjs, if I try to edit, let's add this to the map first. Dot add to map. So yeah, so if I added this point to the map, so the marker will not be available here. That means in Turfjs, one thing I noticed is that it will store the longitude first and then latitude. In leaflet we have to put latitude first is the first parameter and longitude is the second parameter in most of the case, but in the turf it is just opposite. I don't know why it's confusing little bit. So just pass the longitude first parameter and then latitude is the second parameter, and it will be available here. So it's the point from Turfjs. So basically this point feature, it will provide us the GeoJSON data, and then we can directly add it to the map. Maybe I'll try to add the multi-point as well. Multi-point, and for multi-point you have to provide more than 1 point, or 1 point is also enough, I think. So let's just copy these things and then paste it and then change the little bit coordinate 28 to 29. Okay, let's see. So maybe I'll just, for now I'll just remove these layers. So here you can see the 2 points. Basically this multi-point means these 2 points are the same this 2 point will represent the same attribute. So that means if you let's suppose is the school, 2 buildings, so this represent the same school. It's something like this. So this kind of data we can store is the multi point or the multi-line, multi-polygon. Yeah, so yeah, let's add the line as well, var line, and then maybe I'll just copy the code from here. Line string, where is line string? Here. So yeah, so just I'll copy these 2 lines and then just paste it here. So after that maybe I can add the l.geojson and then line string 1 and then dot add to map. So you can do is map dot fit bound, and then I have to make the another variable called line string 1 GeoJSON, and then I can pass the line string 1 GeoJSON dot get bounds, and then map will be automatically zoom into this particular region. So in this way you can just fit your bound to the actual GeoJSON data. So yeah, so I can remove this console log message. So yeah, in this way you can add the line string as well. Similar manner you can create the multi-line string feature as well. So multi-line string is also kind of same line string, two lines but representing the same feature. Maybe the best example of multi-line string will be the road feature. In road feature, if you create the road feature using like the left side road and right side road, but to both line will represent the same road, then it will be the best example of the multi-line string. So also here you can create the polygon feature as well. So the for polygon also you can just type the polygon turf.polygon, and you have to pass the longitude and latitude combination here. Make sure you added the same coordinate in the first and last point, so it will be just make the closed loop, so it will treat it as a polygon. So after that you can just simply load your data, something like this. So maybe I'll just copy this and paste it here, and then I can just write polygon GeoJSON, and then I can just polygon dot add to map and map dot fit bound and polygon GeoJSON dot get bound to get the map in the same bound. So yeah, so here is the polygon just we created from the turf is look like this. So in this way you can create the point line polygon geometries from turf. Here also you can find the other functions as well. So here in the random position, it will give the position, the random position within the bounding box. And best way to create the random data set is the random point, random line string, and random polygon features functions. So maybe I'll create the random point. So yeah, so just copy this line and then paste it here. Maybe I'll just remove everything from map, and then I'll just remove this as well. So if I look back to the map, then this things as well. So the map is clear, so no data is available in the map. And if I added these points random point, and I have to edit to the l.geojson, and then I have to add the points and then dot add to map. So if I added these points to the map, then it will be available all over our bounding box. So something like this. So I can apply this same functionality here in the point data set as well. Maybe I'll create the points GeoJSON, and then I'll write point GeoJSON dot get bound. So it will be available all over the world. If you like to cover only the specific area, you can just update your this bounding box coordinate. So maybe for my case, let's try it to the minus minus 80. I think it's 80 to 80 to 90 longitude, and then latitude will be the 20 to 30. So just try it, and it will, all the markers will be available here. So this first argument will represent the number of markers. So if I try it to the 500 markers, then it will create the 500 markers in the particular bounding box. And then the second argument, this bounding box will represent the in what extent you want to create the markers. So just add, for now I'll add 10, and then in similar way you can create the random polygons. Maybe just I'll leave this as it is, and then I'll just copy this line and then paste it here, and then points to the, I think, polygon, and then I'll create the random polygon, 10 polygons inside this particular bounding box. So it will be looks like something like this. So the different kind of geometry, polygon geometry, will be available inside the particular this bounding box. So it looks messy. Maybe I'll create the only 2 or 3 polygons. So what happened? Okay, here you can see the 2 polygon is available. So in this way you can just create the random data set using Turf. So here you can see in the example, similarly you can create the random line string as well. So the same the syntax will be same, number of line string and then the bounding box of the line string. And also you can pass the maximum length of your line string and maximum rotation as well. So these are the secondary options available in the Turfjs. So yeah, okay, so let me comment out this and this line as well. So now let's try to add something new. So something new means let's try to explain about buffer. So for buffer, if you check the official documentation, here you can find the buffer, how to create the buffer. So it will calculate the buffer for input feature for a given radius. Unit support are mile, kilometer and degree. So yeah, so the basic syntax will be the turf.buffer and then the your feature, and then after that you have to pass the radius and then the unit. So maybe I'll just copy this buffer part, and then I'll just paste it maybe inside this on each feature, maybe in Nepal headquarters data. So let's try it here on each feature, and then function, feature comma layer, and then we can pass the buffer equal to, maybe I can just paste it here, par buffer is equal to turf.buffer, buffer for each feature, and then I'll write kilometer or meters. Kilometers. So kilometers is the default unit, so maybe 5 kilometer, and then I can add this buffer to the map yar.geojson, and then buffer.add to map. So let's try it here. So yeah, it will create the buffer to the each Nepal district headquarters. So if you zoom into the particular region, so it is creating the buffer area based on every headquarter. So this is the headquarter of this Pokhara, this Kaski district, Pokhara, which is Pokhara, and then it creates the 500 I don't know 5 kilometer buffer area within this particular headquarter. This buffer property will be very useful in the some kind of like a rescue operation, or the like. Let's take one example. So near the school area, particularly within the 100 kilometer, you cannot sell the alcohol or drugs. So this kind of things can be restricted using the buffer. So yeah, so in that way you can just add the buffer things here. So yeah, so maybe in the buffer we can write that the in the similar manner we can just pass the on each feature, and then we can pass the function, and then feature and then layer, and then we can pass the layer dot bind pop off, and then this area is nearby HQ, so something like this. So if I wrote like this, and if I click on the buffer area, so it will pop up with the this area is nearby HQ. So yeah, so in that way you can just buffer the area, and then you can just analysis and make the pop-up within this buffer zone. So maybe you can also pass the maybe you can pass the buffer distance. So just this area is nearby SQ, and then you can pass buffer distance equal to, and then your this 5, or you can just pass 5, something like this, and then just save it here. So if you pop up, so it will create the pop-up with this area is nearby headquarter, buffer distance is 5. So okay, in that way you can create the buffer zone within the particular one kind of data. So yeah, this will be really helpful. So let's go to the in the example. So maybe the different this different transformation category. So I'll just copy everything inside this example and then paste it, and uh, I'll I'll just show you how to deal with this kind of things. So here the polygon 1 was created by turf.polygon, and then the polygon 2 also created in the same manner, and then we can just differentiate between two polygons. So for better understanding, we can just add this polygon 1 and then polygon 2 to the map. So let's add polygon 1 dot 8 no not like this, GeoJSON, and then polygon 1 dot 82 map, and then I'll name it as the var GeoJSON, and then this will be var poly GeoJSON 2, and then just write GeoJSON, and then polygon 2.82 map. So the difference will be the let's console log the difference. difference, and then let's zoom into the map dot fit bounds, and then the poly GeoJSON dot get bounds. So let's see. So here we created the two different uh, polygons. So first one is the this big one, which is left side one, and second one is the this inner side one, this one, the longer one, right side one. So if we differentiate between these polygons, so maybe I can show you the result in console. So here it will create the geometry, and then it will just create the difference between this minus this, means this small polygon. So this boundary will be the difference between these two. So if I try to add this different to the map, so maybe I'll create the l.geojson and then difference dot add to map. So yeah, difference is added to the map. So maybe if I remove this and then this one, so it will be the difference between two. Polygeometry is not defined. Okay, just remove this as well, or we can just cut it from here and then paste it here. GeoJSON, and then we can pass the different diff GeoJSON dot get bound. So it will be the difference between these two polygons. So the big polygon was here and then second polygon was here, so the difference between these two is situated here. So if I added this polygon as well, so it's the big polygon. So it's the yeah, big polygon and small polygon, we get the difference between these two. So in similar manner we have this union feature as well. So it will join these two polygons and create the outer boundary only, so something like this. So okay, and the best part of this library is we can check whether the point lies within polygon or not. So we can check this using point within polygon feature. So here it creates the different kind of points using turf.points function, and then the turf.polygon function, and it checks the point within the point within this polygon. So it's the best way, so you can also check. And then here are some cool functions as well. So maybe the convert the geometry to WGS84 coordinate system. So if you pass your point to WGS84, then it will automatically convert your geometry to WGS84. Let me try this example. So here I can write the console.log and then convert it. So here what it does is it creates the point using turf.point function, and then it converts to WGS84 point. So if I console log this, it's maybe I'll just comment out this console, so this one. So here you can see the geometry now is in the WGS84. If you want to convert this to the Mercator coordinate, so you can just do Mercator and then PT. So let's try it as well to Mercator and then point. So let's see the coordinate. So well, so coordinate is in now in the not it's northern format. So this is the Mercator coordinate. So you can just simply convert your point to the this point to the lat long or the Mercator coordinate in this manner. So yeah, so in this way you can also convert length to radian, length to degree, or the convert area. There are lots of features, so you just need this documentation, and then this documentation is really well organized, and then it's the self explanatory. So yeah, you can just go through each of these functions and just try to make some spatial analysis, good spatial analysis. So okay, so I hope you enjoyed this video. If you really like this video, please hit the like button and subscribe my channel, and thank you for watching.